Right, hello again. What we're looking at in this particular video is specifically grade 12 content. Now, the only thing that really changes in grade 12 is they expect you in trig measurement to apply your sine rule, your cosine rule, your area rule, and then also your trig ratios that you learn in grade 10, if it's a 90-degree triangle, to problems in 3 dimensions. So in this case, we're going to specifically be working in problems that involve 3 dimensions. So it doesn't just go left, right, up, down, it also goes forwards, backwards. Now, generally what this means is it means we're going to be working in multiple planes. So the one plane is normally called the horizontal plane. In this case, the horizontal plane is over there, so that's what we could call the ground, I suppose. And then the second plane is always going to be at 90 degrees to that horizontal plane, which is then called the vertical plane. Now, we're going to discuss this pretty much just by doing a couple of examples. And this is example 1 on page 156 in the textbook. Now, in this example, they say, in the diagram, there's a tree, so AD is a tree, and it's perpendicular to the horizontal plane BCD. So that's just a triangle drawn in the horizontal plane. DC is equal to 5 meters, angle DBC is equal to 25 degrees, angle DCB is equal to 28 degrees over there, and the angle of elevation, an angle of elevation is obviously when you look up from a point of A from B, is 37 degrees. So there, that's the information that's been given. Now they say determine the height of the giraffe AD correct to 1 decimal place. So the question is just simply determine AD. Now if you want to determine AD, it's very important to realize that even though AD is located in this triangle right there, which is in the vertical plane, we hardly ever start in the triangle where we're trying to calculate a value. We always start in the other plane and then work our way towards that triangle in the vertical plane in this case. And pretty much it just has to do with the fact that we need information, a certain amount of information, to be able to use the sine rule, the cosine rule, area rule if required, or my trig functions. So in this case, you look at it and you go, I've got 2 angles and I've got an excluded side. So hopefully from the previous video, our revision of the grade 11 content, you'll remember 2 angles and an excluded side means you can use the sine rule. But what are we trying to calculate? And that, very importantly, is always going to be the overlap. So the overlap means the side that gets shared between the 2 planes. So in this case, it's going to be side BD. So we're going to first start in this horizontal plane. We have enough information to calculate side BD. And then the moment we get BD, we can carry that value over into the vertical plane and we can use it in that triangle ABD. Now, very good habits. Please, people, you need to develop these habits. When you work in multiple triangles, whenever you start with a triangle, mention what triangle you're working with. So we're going to start with this triangle, so I'm going to state in triangle BCD. And please make that very clear for the examiner, because remember, you're not just writing this for yourself, you're writing this for the examiner who's going to be marking it in that final exam. So make it nice and clear which triangle you're working at. So in this particular triangle, we're going to say we want to calculate the overlap, which is BD. So we're going to say side BD over the sine of 28 degrees, which is obviously the opposite angle, is going to be equal to 5 over the sine of 25 degrees. So BD is then going to be equal to 5 over the sine of 25 degrees multiplied by the sine of 28. So I can just type it like this. 5 times the sine of 28 degrees divided by the sine of 25. And that is then going to be 5, 5, 5, 4, 3, 2, 1, ... And I'm not going to go and clear my calculator screen here. I'm going to save this. I'm going to go and say shift up here, then store, which is just above the recall button, and then I'm going to type any one of these buttons depending on where I want to store the memory. I'm going to type this button, which means my answer has now been stored under A. And the reason I do that is because we always remind you guys that whenever you do calculations in mathematics, do never ever round off until you get to your final answer. So this is not the final answer. BD was just the overlapping side so that I can move into the vertical plane. In other words, so I can move to this triangle. So you're not allowed to round off yet. And that is why I stored the full value in my calculator so I can use it in the next calculation. But now I'm moving to another triangle. So I clearly state in triangle ABD. And this particular triangle is a 90-degree triangle. So because it's a 90-degree triangle, by the way, you could use the sine rule again if you want, because you've got the two sides, the two angles on an included side. So you're totally allowed to use the sine rule, but I'm generally just going to use the trig ratios, because trig ratios, you're always allowed to use them in a 90-degree angle. So using my trig ratios, I will then go and say, but I want side AD, which is the opposite side. I have side BD, which is the adjacent side. And hopefully you guys will remember that if I put an opposite side over adjacent side, it's going to be the tan of the angle. So the tan of angle 37 degrees is then equal to AD, the opposite side, over BD then, which I calculated over there. I'm just going to put the dot, dot, dot to show I haven't rounded off yet. And that's specifically going to be opposite over adjacent is then the tan of the angle. And please remember, you're only allowed to use these ratios in a 90-degree triangle. 90-degree triangle. So I can then go and I can say AB is going to be equal to that times that. And luckily I still have it over here on my calculator screen, so I can actually just go that times the tan of 37. So that's going to be 4,2, and that's going to be in meters, rounded off correct to one decimal place. Just by the way, people, in case you've forgotten your trig ratios, the sine of any angle is equal to opposite over hypotenuse. The cos of any angle is equal to adjacent over hypotenuse, and the tan of any angle is equal to opposite over adjacent. Now please people remember, this only applies to a 90-degree triangle. So this is only in a 90-degree triangle. It does not work if the triangle is not a 90-degree triangle. And I think most of you have that mnemonic device. Mnemonic device, just the sounds. You memorize it by sounds, where you go so, ka, toa. So please remember, this is what I'm going to be using, but you are perfectly allowed over here, if you want to try it, to use the sine rule. Okay, right, let's do another example of these. Hopefully you guys will get this as we go along. Now this particular example is example 2 on page 156 of the textbook. So this one, and if I just find the information, says there are only 3 brick goat towers in the world, and one of them is in the Fairview Winery in Powell in Western Cape. In the diagram, the goat tower, so you've got the goat tower AB, so that's representing a goat tower, stands in a horizontal plane BCD. So it stands in this horizontal plane. Now you'll notice in the previous example that I actually go and I highlight that horizontal plane. It actually makes things just a little bit easier to see. So you'll see in all of the examples that I'm going to be doing, I always highlight that horizontal plane, just so you know this is the ground and these two are in the vertical plane. So this is at a 90-degree angle to that horizontal plane. Okay. Now the recent information they give me is they told me angle BDC, so from B to D to C, this angle is 44,8 degrees. Side BD is 70 meters, so side BD is 70 meters. Side DC is 52 meters, and angle ACB, so from A to C to B, this angle right there is 30,7 degrees. Now the question that they ask is calculate the height of the tower correct to one decimal place. So the height of the tower is then pretty much calculate AB. And again, even though AB is located in one of these two 90-degree triangles, we can never ever really start with those. Why? Because we don't have enough information. We generally go and we start with another triangle that has got enough information for us to at least do some calculations, which is this bottom triangle, and I'm going to write that out again. Again, people, please, good habits, write down which triangle you're working in. So in triangle BCD. Now in this bottom triangle, right there in the horizontal plane, I will go and realize I've got two sides and an included angle. Now, again, from the previous video, which is revision of the grade 11 work, two sides and an included angle means you have to use the cosine rule. Now, if I have those two sides and an included angle, it allows me to calculate this side right there, which is opposite that included angle, which is great because, as I explained to you in the previous example, we want to calculate this overlapping side so we can carry it over into the next triangle, into the next plane, specifically here the vertical plane, and then we can use it to calculate AB. So our plan, and it's very important to plan ahead, is we're first going to work in this triangle, and we're going to use the cosine rule to calculate that side. Now, because that side overlaps with this triangle, the vertical triangle over there, I can then go and I can calculate using that value in the vertical triangle. I can use AB. So first we'll start in triangle BCD. So in triangle BCD, we're going to say BC squared is then equal to 70 squared plus 52 squared minus 2 times 70 times 52, and then careful, times the cos of that included angle, which is 44,8 degrees. There we go. And I'm going to just type that into my calculator. So 70 squared plus 52 squared minus 2 times 70 times 52, and then the cos of 44,8 is then going to be equal to 2,438,325 ... but then obviously we still need to go and calculate the square root of that to get to BC. And that's going to give me 49,379. And again, I'm going to store that because this is not my final answer. And remember, we're only allowed to round off at the very last. So I'm going to go again and go shift, store, and then any of those, I'm going to store this one under B. So it says my answer is now in B, so I know when I want to go look it up, it's in B. So now I move into the next triangle, which is the one that shares that side BC. So that's going to be in triangle ABC. And that triangle right there is a 90-degree triangle. I know it's a little bit difficult to see in this three-dimensional diagram, but you can, if you really want to, you can redraw it. So you can say, if you look at it straight on, so if you stand over here and you look at that triangle straight on over there, you'll notice if it's got the 90-degree angle there at B, there's A, there's C, and that's the 30,7-degree angle. And that means you can then just go and use your ratios because this is in fact a 90-degree angle. Now, I want this side right there. This is the one I want, which means I want this side, which is my opposite. I've got this side, which is over there, so that's my adjacent. So opposite over adjacent is again going to be tan. So the tan of 30,7 degrees is then going to be equal to opposite AB over adjacent, which is then that one that I calculated, the 49,379, and again I'm just going to go dot, dot, dot. There we go. So AB is going to be equal to that value times that value, which I already have there in my calculator screen, so I can just go and say it's the 49,379 times the tan of 30,7. And that means it's going to be equal to 29,3, and now I can round up to one decimal place. And that is going to be in the same units, which is meters. And that is then the final answer, 29,3 meters. Right, so that's pretty much the examples I wanted to do today. I have given you some homework on this. It's actually quite useful just to go through the homework and start trying to do these examples. But if you keep to those tips that I've shown you, which is pretty much generally, you always have to go and start in the triangle where you have the most information. And that means you always need 3 pieces of information to do anything in a triangle, be it 2 sides and an included angle, 2 sides and an excluded angle, 3 sides. You'll notice in the previous video that we did on the revision on the grade 11 content, you always need 3 pieces of information to continue to go ahead. So you always start in the triangle where you have those three pieces of information, and then you always work towards an overlapping side, a side that's shared between two triangles. Generally the side that splits your horizontal plane and your vertical plane. So you always work towards that side, and then you go into the next triangle to calculate whatever it is that they ask of you. But people, please, 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 please remember to do this. This is just very polite, and also it's quite nice and easy to see the way that you're working. And also I always tell people, don't be scared to go and redraw the diagrams, because a lot of the time some people struggle to see these 3D views where they can see this one just fine, but they can't always see what this one is. So especially if you're an art student or an EGD student, we know all of the different ways to draw the different views of an object. Just change your view. Just change your view, and then the problem actually becomes really easy to do. Right, so good luck with the homework.